Hello all, this is Dr. Anand Nayyar. Subscribe to my YouTube channel Gyan with Anand Nayyar for latest tech videos on unboxings, server administration, embedded systems, cloud computing, simulations, big data, Linux administration, research methodology, ethical hacking, and many more. Hello researchers, how are you? I hope you are fine and doing well. In this video, I will be demonstrating what is meant by Network Simulator, that is NS-2, and how to install Network Simulator 2 on Ubuntu 16.04 and Ubuntu 17.04 in step-by-step manner. Now before we proceed, let us have some introduction what is meant by Network Simulator. Network Simulator, or NS, is a name of a series of discrete event network simulators, specifically NS-1, NS-2, and the latest one, NS-3. All of them are discrete event network simulators primarily used in research and teaching. If we talk of NS-2, NS-2 began as a revision of NS-1. In 1995, NS development was supported by DARPA through the WIND project at LBL, Xerox PARC, UCB, and USC/ISI. In 2000, NS-2 development was supported through DARPA with Salmon and through NSF with Conser, both at USC/ISI in collaboration with other researchers including ACIRI. NS-2 incorporates substantial contributions from third parties including wireless code from the UCB, Delidus, and CMU Monarch projects and Sun Microsystems. For documentation on recent changes, see the version 2 changelog. Now on the computer screen you can see the official website of NS-2, which is isi.edu/nsnam/ns. On this website you can find all the basic notes, that is getting started to NS, avoiding problems, documentation, helps, additional notes, and even you can contribute your code as per the requirement of NS consortium. Now let us start with some PPT in which I will be demonstrating the basic aspects of NS-2, some basic module of simulation and other things. In order to proceed, let me tell you some more details regarding simulation framework or the workflow. The general process of creating a simulation can be divided into several steps. The first step is known as topology definition. To ease the creation of basic facilities and define their interrelationships, Network Simulator has a system of containers and helpers that facilitate this process. Number second is model development. Models are added to simulation, for example UDP model, IPv4 model, point-to-point protocol, and links and applications, and most of the time this is done through helpers. Number third point, node and link configuration. Models set their default values, for example the size of packets sent by an application or MTU of a point-to-point link. Most of the time this is done using the attribute system. Number 4 is most important, is execution. Simulation facilitates generate events. Data requested by the user is logged. Number 5 is performance analysis. After the simulation is finished and data is available as a time-stamped event trace, this data can then be statistically analyzed like tools of latest languages like R programming language to draw some different conclusions and proper analysis. Last but not the least is graphical visualization. Raw or processed data collected in a simulation can be graphed using various tools like GNUplot, Matplotlib, or XGraph. Basically in NS-2 we use XGraph, but in NS-3 you can even use XGraph, but the most important thing is GNUplot. So let's go with some presentation in which I will be highlighting something more about NS-2. So hello everyone, this is the introduction to NS-2. I, Dr. Anand Nayyar, I have done my PhD computer science, and here is my professional email ID, research@anandnayyar.com. You can even visit my website, that is anandnayyar.com, and if you need any clarifications in NS-2 you can mail me over here, and if you need this PPT even, you can mail me your request on this email ID. I will mail you as soon as possible. So let's begin. What is the core of NS-2? Discrete event-driven network simulation. It is purely object-oriented. NS-2 is an extended TCL OTCL interpreter that is called Tool Control Language. NS-2 is written in C++ and OTCL, and OTCL stands for two things, that is TCL plus OO. TCL stands for Tool Control Language and O stands for Object-Oriented Language. C++ implements the code that executes frequently, and OTCL configures the overall system of simulation. Maintained through Wind Project NS2 collaborative simulation environment, it is freely distributed and open source, which means that you can even download the code and you can freely distribute it and you can even contribute your code or even perform some bug-based analysis and develop into it, support anti-research and education, protocol design, traffic analysis, etc. And it provides common reference. So the most important points. Now let us take some history for NS2. In 1995, it was developed by LBL through the support of DARPA. In 1996, NS was extended and distributed by the Wind Project. 1997, satellite models added at the rate UCP Barclay. In 1999, wireless models added at the rate CMU, recent incorporation of emulation. So current release, if we talk of, that is periodic release is done. So currently it is 2.27 or I can say 2.35 January 2004, but now the version is also shifting to 2.35 and now we have the NS3 simulation also. So daily snapshots probably compiles and works but unstable, available from USC, ISI, UC Berkeley, UK Mirror and more than 10,000 users from hundreds of universities. So what are the platforms where NS2 can be installed? So most Unix and Linux based systems, that is free BSD or BSD, Linux, Sun Solaris, HP and SGI, Windows under Cygwin. So I don't recommend Cygwin. I recommend you to install it either into Fedora or Red Hat and preferably Ubuntu, because in my doctorate work I have also used Ubuntu 15.04 in order to implement my protocol, which was based on sensor communications. Now, what are the components of NS2 package? The first and the most important component is TCL/TK, that is NS2 is an extended TCL interpreter, OTCL, that is Object TCL, TCL with classes library, NS2 main simulator, NAM, which shows the network animations, that is called network animator, XGraph for plotting all the graphs as well as all the results, and many more. So here is the picture I have taken from Wiki. From the picture, it is very much clear that the NS2 simulation contains architecture which is aspect into three aspects. The first aspect over here, you can see that there is a OTCL script in which contains network topology, in which we design the network, and after that we have the traffic scenario. It is given to NS2, which interprets all the information via OTCL interpreter, and we have the C++ library, and after that network animator gives us the simulation result, the trace file, and we get the simulation result and trace file format using the trace graph, which is known as the XGraph. So which means via programming, interpreting as well as analysis. So what are the pros and cons for NS2 simulator? With my thorough research, I was able to draft all these things. First of all, let us discuss something about advantages. It is free. Almost all network components are implemented, which means we have wired as well as wireless. But still, the latest technologies like LTE or I can say WSN, so it is not very much highly reliable into these type of NS2 simulations. Active contributions from researchers, but now we don't have active contribution in NS2, but we have the active contribution towards NS3. But still, it is contributing, the codes are being there. It is easy to modify and add new functions. It is unreliable. Because why? Because still it is having some unstable code. There is no technical support. You are only dependent on some professionals and firms in order to get your problem solved. It is somewhat hard to troubleshoot. You can see that if there is some problem in the code, then the code has to be very much hard to troubleshoot. It is having some unrealistic and abstract model, and it contains bugs even till today. So which means even though it is contributed by various contributors, but still it is containing some bugs. It is not even stable till today. So let us discuss something regarding discrete event simulator. NS2 is a discrete event simulation, and all the physical activities are translated to events. And what are events? Events are queued and processed in order to have their scheduled occurrences, and time progresses as the events are processed, which means transferring the packet from one thing to another thing is even called an event. So you can see that the node 1 is transferring the packet. It has taken the time of 1.5 seconds, and then the node 2 has received the packet. It has taken about 1.7 seconds. So time, you can say again 1.8 seconds, and again time received by that is known as time 2.0 seconds. So TCL interpreter with extends. So we have OTCL, which is having object oriented support. We have the TCL, that is CL, C++ and OTCL linkage. We have the discrete event scheduler, data network, the internet components, and you can see it is having TCL 8.0, and then we have the OTCL, then we have that is TCL CL, and then we have the event scheduler, and here is the main graph over there. So here we have the network components, and here we have the complete NS2 event. So now let us discuss something regarding the hierarchy for NS2. Hierarchy for NS2, it is very much important to understand in order to do some programming of NS2. TCL object is connected to NS object. It is divided into two components. One is called classifier and the second is called the connector. And under the classifier we have the area, that is the address, replicator, mcast, empath, hash, and over the connector we have the delay, agent, application, queue, and trace. So in order to further understand the hierarchy, we can have the something regarding the most important thing which you can see on the screen right now. We have the agent which contains UDP, TCP, DSTV, AODV, TORA, and DSR. So all these protocols are inbuilt into NS2. So if you are coding some new protocol, try to use these protocols as the base protocol and then try to implement your own protocol by improvising with some features, with some analysis, with some graphs, etc. So we have the Reno, we have the application, we have the queue, and we have the trace. So all these are basic components which are being added to NS2. So now let us study the NS2 directory structure. So we have the simulator and we have the different folders which are over there, that is TCL 8.0, TK 8.0, OTCL, TCL, NS2, and NAM1. And under NS2 we have the TCL, we have the example folder, we have the test folder, and we have the library files. So here it contains the C++ code, and over here we have the TCL code. And over here in lib we have the TCL code core. And in the test we have the validation test, and EX stand for examples. So let us study something regarding the NS2 environment. Now you see on the screen we have the first of all C++ implementation, which means first of all we code in a proper C++, and then it is converted to TCL script which says that is set NS. It is again a parameter to constraint of a new simulator. Then we set two type of nodes, that is set node 0 and set node 1, which means the two nodes network will be there. So you can say with the set node 0 it will be 1 and set node 1 it will be 2, and here will be the simulation scenario. So you can say that it is a very simple to understand, but we have to understand the proper TCL and OTCL script in order to code and to make our own network simulations. So why we have the two important languages? Most of the people ask in different conferences and forums that why we are using two languages into this NS2 simulation, why we use TCL, that is tool control language, and why we use the C++ and it is a mixture for two. So why C++? It is detailed protocol simulations require system programming language. Because why? Because in order to program any new protocol, it is very important to do system programming. Because suppose that if you are generating a sensor network and you want to implement your own new protocol in order to make the packet flow, in order to have the energy efficiency, or if you're coding regarding minutes or time synchronization, etc. So you need to understand the system programming, and for the system programming it is most important to do the programming into C++. The most important things are byte manipulation, packet processing, algorithm implementation. Runtime speed is very important, and turnaround time, which means running the simulation, finding the bug fix, recompile, and rerun is slower. So all these main functions is performed by C++ programming language. And TCL, simulation of slightly varying parameters or configurations, which means that we want to vary some models or we want to generate a new number of scenarios or iteration time. So the TCL language is very important. So which means that C++ and TCL combines your network scenario in order to implement the workflows as well as to research on new and new protocols in order to make your own systems or new systems run with your protocols. So the third point which is very important is data and control separation. C++ for data, per packet processing, core of NS, fast to run, detailed, complete control. And OTCL is for control, which means that there are two aspects for NS2. One is the data and second is the control. So for control we have the simulation scenario configurations, period and triggered actions, manipulating existing C++ objects, and it is very fast and easy to change. So running versus writing speed, learning and debugging. So that is the reason we have the two most important languages as the separated languages and the combined languages for NS2. Now where to find what? Now suppose we have the folder, and then that folder only we will be working and installing it. So we have the TCL box, we have the TK box, OTCL box, TCL NS2 which contains the pure C++ code. We have the NAM folder which contains the network animator files. So the TCL contains the OTCL code and it contains the three subfolders. One is known as the example, test stands for validation test, and lib stands for OTCL source or the library files. So where to find what? ns-lib.tcl, the simulator class and most of its member function defines the except for LAN, web and multicast related ones are located there. ns-default.tcl, the default values for configurable parameters for various network components are located here, which means all the basic components for network, whether it is your nodes, whether it is your FTP, UDP, everything is located under this TCL script, and the parameters are actually C++ variables. We have the bind, that is C++ variable name, and the OTCL variable name. So we can say that with the bind function we have the two parameters which we pass, that is C++ variable as well as the OTCL variable. The next thing is called the ns-packet.tcl. The packet header format initialization implementation is located, so which means everything regarding from the packet header to register the packet, packet initialization, offset pattern in the stack, everything is located in the ns packet. Another TCL files which contain the directory file, the FTP application, so everything is source code located under the other OTCL, which means object tool control language files. Now let us see one of the most important code which I have drafted for this video, that is creating a simulator object. In order to define a new simulation, we have to go with set ns. ns stands for new simulator. Setting up files for trace and nam, which means in order to find out the trace files to analyze the figures and the nam in order to find the network animation, we have to use two main functions, that is set trace nam, which is open out.namw, and set trace all, which is open for trace files. And tracing files using their command, so set nam trace all to trace nam and ns trace all to trace all. So code for simple topology, under that closing trace files and starting nam. So process is finished, so all this code is being there, so I will not read the code. You can see the code and you can pause the video right now so you can see and close the code. So over here we contain the simple node and topology, which means when we create the nodes and we create a link between them, so you can see over there, so we have created 4 nodes and we have created 2 routes between them. So N stands for nodes and R1 stands for NS nodes and set route ones. And here we create the links in which we have created the duplex links. So it is between, that is the time is specified as well as the speed is also specified. So the drop tail is also there, so you can see over there. And now it contains the orientation of the links, so whether it will be transmitting it right or right up or right down, so you can see. And here it will be generating this type of topology. So you can say that about 5 nodes are being generated and they are properly being located, and network simulation will be started. So this is the basic topology that we have simulated in NS-2 simulation. So getting the traffic, you can see this code which we will be getting the TCP based traffic in order to transmission of the protocol. And attaching some application, here I have attached the FTP based protocol, so which means that we will be transferring the FTP based request from node 1 to node 0. So this is the time at which we will start the FTP from 0 to 1 and we'll stop the FTP from 1 to 0. So it will finish and make the NS run. So here you can see that it will create this type of topology with the trace.nam. So why are we linking OTCL and C++? So here you can see in the diagram, again I have taken this picture from wikipedia.org. So pure objects are there and pure TCL objects are there, so they have the proper collaboration between them. So how the NS2 works, you can see that object A and object B, we have a scheduler, we dispatch, we dequeue, we event queue, target queue, etc. and register the events. So here you can see the example of a wireless channel, that is there is a wireless channel, so net IF, MAC, IFQ, scheduler, etc. is all over there. So what are the troubleshooting basic problems? So problem while installing, check known errors, program crashes, unexpected results, hidden problems, and TA doesn't fix your problems. So here are the following most important resources which you can see, and I will leave all the links down in the description below. And apart from it, you can read some of the books like NS2 manual or NST, some complete reference, or you can go to books.google.com and you can download some books over there. So here is the PPT. Here we end the PPT of this video, and now let us move to the part 3rd of my video of this of NS2, in which I will be taking, that is Ubuntu 16.04 and Ubuntu 17.04 in order to install. So let's start the installation. So let's go to Ubuntu 16.04 first of all, in which I have already installed the fresh version of Ubuntu so that I can be able to demonstrate how to install NS2 simulator on Ubuntu 16.04. So here are the series of steps. So you will say that why I am using two Ubuntu distributions in order to install NS2 simulator, because when I was researching I was able to find that the same installation steps cannot be there for both Ubuntu systems. So Ubuntu 16.04 is one of the very good and the prominent operating systems, when Ubuntu 17.04 is the forthcoming, or you can say the latest which has come. So you can use both any operating system in order to install NS2 simulator. So these are the steps, and all the steps will be available in the description below. And you can see that I've already copied NS all-in-one 2.35 version, so you can download from here. And if I go to this properties, you can see that it is about 60 MB of simulation. So let's not waste time and let's start with the installation. So I'm using the same of my home user. If you say that pwd, it is saying that is home/Anand, and it is known as the username for Ubuntu. So I will be using this in order to install my NS2. So the first thing is to update the system, that is sudo apt-get update. So let's give the password. So it will start the update. So it will take some time depending on your net connection as well as international server speeds. So it has connected. Okay, so system has been updated. So let us start with the pre-installation commands or the repositories which are being required in order to install Network Simulator 2. So apt-get install build essentials autoconf and automake. This is very much required. So if you follow steps, you will find no issues in order to install NS2. It is very easy to install. Just follow the steps. So you can see that it is about 1 MB of archive and it will take about 4 MB of disk space. So after that we have to install, that is the TCL as well as the TK 8.5 dev, which are the most important components for NS2 simulator. So let's copy this and let's wait for the installation to complete. Sometimes 16.04 takes some time in order to install the repositories. So yes, it is done. So let's clear this and let's paste the another command. So it is about 5 MB. So let's press yes and press enter. So after that we will install the other components, that is sudo apt-get install perl, xgraph, libxtdev, libx11 as well as libxmudev. So make it sure whatever the steps I am doing, I am again repeating in my video. Please follow the steps. There will be no problem and issues. Everything is going in front of you. So you will be installing the NS2 without any hiccups. So let it get complete. Almost done. Yes. So you can say it is working very beautifully. So it is setting up TCL 8.5 as well as the TK 8.5. It is set. So let's clear and let's go with the last basic parameter. So we require just 198 MB. So it is all done almost. And after that, till it extracts, we just go to our desktop and we just double click over here and we just extract the NS all-in-one over the desktop. So you can see the extraction is being in process. Okay, so it is done. So let's close this. So you can see the folder is being there. So if I double click the folder, you can see all these folders which are there. So I have already labeled what the folder is all about. So everything is over there. So network animator, xgraph, TK, TCL 1.5, NS 2.35, OTCL, all this contains everything. So even you can say that the readme file is also there. You can see everything. So it is again a very good resource for you in order to understand. Okay, so let's close this. And let's continue with this part. Now, before I go with the installation part, so what we have to do is to just go to the folder that is desktop, ls. So let's copy everything from NS all-in-one to /home/ Anand. Okay, so don't worry. So I just go over there. Okay, so no problem. We can continue over here itself. So before we go over there, okay, we can do one thing. We can just copy this ns all-in-one .tar.gz to our folder, that is /home/Anand. So let's go over there under our pwd, make it sure that it is there. So let us ls. So over here we have, so let us give this command tar space -xvzf ns all-in-one.tz. So it will be extracting everything over here. So you can extract it from desktop even. So let me remove it from the desktop. So about 6,000 files are there. Okay, so all set. So let us go to this folder, that is cd ns all-in-one, and we just, before installing, let me make it sure that we have to do this step. So cd ns, and over here we have a folder that is called link state. Okay, so over here we have a file called, that is called ls.h. Okay, so you can see that there is a file called ls.h. You have to open the file. So gedit ls.h. So go to this line number 137. So I've written over here even. So over here you can find in the notes. So we have to just write this at the line number 137. So where it is, just go to line number 137. You can find over here. So line number 94 is there. This is 114. So 137 and yes, so line number this is there. So you can see the line over here like this, 137 line. So type over here, that is this hyphen and this one. So this to the point erase. So it is a bug we have to solve. So unless, if you don't do it, it will create a problems in your installation. So save this file and click on close. So let's close, So let's close this, and just now let us go one thing to cd double dot, and here we have the installation. So without any problem, just type /install and press enter. It will start with the installation, and it will take about 10 to 15 minutes to install, and after the installation we will continue. So till then I pause the video and let's meet after the installation. So you can see that the installation is going on. It is about 10 minutes now that I've already started, and the installation is still going on. So we have to wait more. So you can see that the installation has been completed. So here you can see that there are some instructions which is over there. So do one thing. You just have to type cd double dot, and you just have to go to this command, that is sudo gedit bash rc, so that we can able to set the environmental path of all our OTCL, NS-2, NAM and all the library files. So let us paste this, and now come to the last of this line, and I will be providing that. So make it sure that you copy everything, but when you install in your own system, replace this with your username. So where I've written Anand, replace with your own username. So copy from this till this. Let's copy and come to the end of this file. After V, you can make it sure that nothing is over below. So Control V. So everything is being set out of here. So save it, close it, and now what you have to do is to type in this command, that is source bash rc, so that everything can be set out. Copy and paste and press enter. So now if everything is okay, let's validate the system, that is cd/ns. So cd ns and /validate, and yes, voila, it can take up to 1 hour 30 minutes to run. So no need to run this. So let us go to some other console, another terminal. So let us type the word ns. So this percentage means that it is running. So we have stopped it, and let's type nam. And yes, you can see that the network animator has started. So let's go to new NAM editor, and you can type your, and you can see that you can take your own nodes, you can place over here, and you can start working with NS-2. So this is basically the installation which has been done on 16.04. And now let's go to the last part of this video, in which I will be demonstrating how to install the same NS-2 simulator on 17.04 Ubuntu. So let us shift to this machine. You can see it is Ubuntu 17.04, and here let us unlock it. So now you will ask me that why I am installing this over here. So the main thing is that we have to go with some additional things in order to install NS-2. So let's go to the terminal and let's start with our files. So you can say that everything is being set out over here and all the notes will be available. So let us go with the first thing, that is sudo apt-get update. So let's give the password. So let me tell you till it updates. So till then over here, this one, you can see that this is over there. But in order to overcome all the X file window errors, support latest 4.9 and setting up the path, so these three are the additional things which has to be done. Rest everything is the same. So let us install over here so that I can demonstrate more to you. So let's go with the basic installation, that is sudo apt-get build essentials. So let's control C and control V. So let's press enter. Again 1 MB. So you can see that installation of NS-2 in 16.04 was a breeze, and even we can make it breeze and very much smooth in 17.04. Just follow steps. So after this we install, that is apt-get install TCL 8.5 dev and TK 8.5 dev. So let's copy this also. So depending on the net connection, it will not take much time. And the setting up, as you all know, it is very fast, smooth and easy in Ubuntu. So let's clear this and let's shift Control and V. So again 13.4 MB of file, so it can take some time. And after that we install, that is your library files Xgraph and Perl with this command. So let's copy this and let's wait for this to complete. So some people say that NS-2 is a challenge, NS-2 is very tough to install. So after this video you see that I can even bet on it that installing NS-2 will not be a challenge for all of you. And almost same step can be performed in other operating systems depending on some basic clarifications. If there is some error, you can just Google that error. The forums are very much good and you can easily find the solution for it. Even when I was doing my research on this, so there were some errors, and even have troubleshooted some errors so that I can make, when I make the video, I should be error free for 17.04. But 16.04 was you can say just a breeze in order to install NS-2. So almost 53% is there. So it will take less than 20 seconds now. So almost we are done. Yes. So the setup will be starting. Yes. So two things are done beautifully. Okay, great. So let's clear this and let's paste this. So again 658 KB, so not a big thing. It can easily be installed. And after that, in order to overcome all the X window errors, if you don't do it, if you go for this installation, it will give some errors. So make sure that you install like this. So this will not take much time. Okay, so let's proceed with this. Okay, so it is done. So let's go with this installation of G++ 4.9. Let's paste. So it will take about 2 to 3 minutes to download. So till then we pause the video for some time. So you can see that the G++ has been installed. So now we come to the last step in order to begin the installation of NS-2 on Ubuntu 17.04 in order to export this. So it is done. So now we are all set. So on the desktop I have already copied the NS. So we just copy to this, that is copy NS all-in-one to /home/Anand. So there will be the path. Okay. So let's extract the So let us check first of all. So you can see that it is done. So let us extract over here, that is star space minus xvzf ns all in one. So again we have to troubleshoot that bug, as I've already told you in the somewhat back time. So cd ns all in one, cd ns, cd link state, and over here we have the file that is gedit ls.h. Okay. So again you have to go to line number 137. So okay, so there's line number 137. So this hyphen and that erase and click on save. So let's close this file, and now we are all set to install. Double dot clear. So here we have the install. So just type in /install and press enter. So till it installs, we pause the video. So you can see that the installation is going on, and it has taken about 15 minutes to reach over here. So still we have to wait. So now you can see that the installation has been done. So let's full screen it. And now what we have to do is to come to the same final steps. So cd double dot. So over here we have to go with this sudo gedit bashrc. Same we have done in 16.04. So click on paste. And now what we have to do is to paste everything over here. So same everything. No change, or just change my name with Anand with your username. So I just go to the downstairs and make it sure nothing over there. So Control V, save it, close it, and let's begin with another command, that is source bashrc. Okay, so now let's clear, and now let us go again with this ns1 cd ns and dot validate. So yes, voila, we have done. So let us come outside. So let's type ns, it is saying good, and let's type nam. You can see that the network animator is also there. So let's click on new network animator, and now you can see I can place the nodes, everything over here. So this completes this session. So in this video I have demonstrated what is NS2, what is basic fundamentals of NS2 via PPT, basic terminology, how to create a simulation file, and after that I have demonstrated how to install NS2 on Ubuntu 16.04 and 17.04. So I hope that you do like this video, do share with your friends, do give this a shot. Thank you so much for watching.